I'm glad you decided to watch this review of Green Book assignment number 3 with irrational complex numbers and rational expressions. It's going to be a worthwhile review. Let's start with a radical equation. So if you have a radical equation, first thing you want to do is get the radical by itself, but in this case it already is. What you want to be thinking about is, what can I do to get rid of this radical? I don't like it. And hopefully you said, well, I'd square both sides. Definitely. Square both sides. Be really careful when you're squaring this binomial though. Write it out twice. It's a rookie mistake to square both terms. You got to write it out twice. Then on the right side, distribute that out. Now, you've made it a lot easier. You've got a quadratic equation. You're going to try to get a 0 on one side, factor, and solve. Okay, why don't you play the recording when you've got your answers? Okay, so we get 0 on one side, factor it, solve it, and now we need to check to see if it really checks. Okay, because we could have extraneous solutions. So when we sub in the -2 for x, it works. We sub in the -1 for x back in the original equation, it also works. But again, you do want to check. There could be extraneous solutions. Second type of question involves the nature of the roots, which is going to involve using the discriminant. This type of equation doesn't say what are the roots. It says, what kind of roots do you have? Are they imaginary, are they rational, irrational, etc.? So, we want to evaluate the discriminant, the b squared minus 4ac. Okay? So first off, we're going to identify what a, b, and c are, and then just substitute into that discriminant, that b squared minus 4ac. So why don't you figure that out, play the recording when you've got your number. Okay, so hopefully you ended up with 96. Now you have to think about where that shows up in the quadratic formula. It's under the square root. So if you did do the square root of 96, would you get an imaginary number? No. Would you get a rational number? No, because that would be if you had a perfect square under the square root, you'd get a rational number. So it's got to be choice 3, irrational number. All right. We'll just put a little dot on that one. It's got to be choice 3. Great. Next one. This question says, find all values of k in this equation that has a k in it such that the roots are imaginary. Well, again, we don't know what the roots are, but we know the characteristic of the root is that they're imaginary. That means the discriminant has to be a certain thing. Think about what kind of numbers under a square root make imaginary. And hopefully you said, well, it would have to be a square root of a negative. So what that means is the b squared minus 4ac, the discriminant, is negative. And the way we write that in a symbol is less than 0. So now sub in all the stuff you know. A is 3, b is -2, c is k. So we got to sub in a k for c. So now you sub in all the values you know, simplify, get the solve for k by subtracting 4 from both sides. Now you have to be careful here. We want to divide by -12 to solve for a k, but we have to switch the sign here. Okay? Switch the sign to be a greater than when we divide or multiply an inequality by a negative. So you end up with k is greater than 1/3. Another way to write it would be in interval notation, parenthesis 1/3 to infinity, parenthesis. Next question. We're given a root and we want to find the quadratic equation that has that as one of its roots. So it's not going to tell you in the problem to use sum and product of roots, but you need to know, use sum and product of roots in this case. First thing is, do you know what the other root is? There's an implication that the other root of this is 3 plus 4i, which is the conjugate. Okay? So you've got your sum of root and product of roots formulas. Negative b over a and c over a. Write those down. Now, we know what the other root is. It's 3 plus 4i. So you're going to figure out the sum of the roots. So 3 minus 4i plus 3 plus 4i is how we add up the roots. You get a 6. And then you just set 6 equal to negative b over a. I find it's easy to put 6 over 1 so that the a has something to match up with. So we know therefore a is 1, 6 is equal to negative b, therefore b is equal to negative 6. We have 2/3 of the things we wanted to find. We wanted to find what a, b, and c are. Let's use the product of the roots formula to find out what c is. Now, for product of the roots, you need to multiply those two conjugates. When you multiply them, you get 9 minus 16i squared. Do you remember what I squared is? It's negative 1. So that makes 9 plus 16, or 25. Now that means 25 over 1 equals c over a. And now we've got it that c is equal to 25. So remember, the a, b, and c are the coefficients and the constant in the quadratic equation. You just put those into place. Make sure you're writing an equation. It stinks to have done all this good work and not put the equals 0. But the equals 0 is necessary in order for us to have roots such as 3 minus 4i. Next question says, express in a plus bi form the roots of this equation, which is a fancy way to say, solve it. It's also giving us a hint. It's telling us that the roots are probably going to be imaginary. Of course, you can express real numbers in a plus bi form. You just don't have a b part. But it would be very rare for them to ask the question this way and not have I in the answer. So expect there to be an I in the answer. Think about what that means about the discriminant if I is in the answer. Hopefully you recognize that means the discriminant is a negative value. So on your paper, let's write down the quadratic formula. Then play the recording when you've got it written down. Okay, so hopefully you wrote down the quadratic formula. We'll sing it together. X equals negative b plus or minus square root b squared minus 4ac all over 2a. I've got the discriminant in red. Let's make that stand out because we're going to work that out first. But there's a preliminary step. Hopefully you recognize over here on the right, the quadratic equation is not written in standard form. We need to get a 0 on one side before we can identify a, b, and c. And most of you, I'm sure, recognize that. Now we can identify a, 1, b is negative 4, c is 5. Sub those numbers into your discriminant value. I find it's useful for students to work out the discriminant value first. Okay? So, we sub in those values, do the simplification here, comes out that the discriminant is negative 4. Well, that's no surprise. We had said before we thought because of the imaginary roots, the discriminant would be negative. Okay? So, substitute now into the quadratic formula. Okay, we sub in all the other stuff, the negative b and the 2a, as well as the discriminant. Now it's easy to simplify. Remember, square root of a negative 4, 2i. Now we just need to break this down. I put 4 over 2 plus or minus 2i over 2. Simplify those, 2 plus or minus I. Now we're going to move to some fraction types of questions. Rational expressions, rational equations. First question involves a complex fraction. This was something we learned new in this class. It's a fraction within a fraction. We don't like it. We want to simplify it. And the way we're going to do it is we're going to look at all those little denominators, the r, the s, and the s squared. We're going to identify their LCD. Okay? Hopefully you identified that it's rs squared. Let's multiply everything by rs squared. And if it's a fraction, let's put it over 1. So, if we do this correctly, all those little denominators will divide out. They do. So, write down what you think is left when you simplify by multiplying by that LCD. Okay? So, hopefully you got this. S squared, because the r's divide out. RS, because one of the s's divides out. Bottom left, the s squares divide out, so we get r times r squared. Careful here. We don't divide out the r's. They're both in the numerator. And this we're just multiplying. We get rs squared. This is the answer. It's just not simplified. Factor. If in doubt, factor it out. Up in your numerator, you've got a GCF. Denominator, you've got a GCF. Okay? S and r respectively. I see some factoring that can take place down in this denominator. It's a difference of 2 squares. Factor that out. R minus s, r plus s. At this point, I want you to recognize we have not the same factor here, they're opposite factors. We divide them out, but we don't get a 1. Instead, we get a negative 1. You can put the negative on top or bottom. I chose to put it on the top. Negative s over r times r plus s. Next question involves multiplying and dividing. So we know division of fractions is the same as multiplying by the reciprocal of the divisor, the fraction that's doing the dividing. So as you're rewriting it, let's rewrite this as a multiplication of the reciprocal. We also know that this problem can be a monster if you just choose to multiply across. Instead, factor. Factor everything. We said in this unit, if in doubt, factor it out. Factor as much as you can, and I'm guessing many of the factors will divide out. So there's an initial factorization. Of course, I've written this as the reciprocal. This in the numerator can be factored further right here because it's a trinomial. Looks like an AM kind of factoring. Okay? Took out the GCF. Now I'm going to factor it further. Now I've factored as much as I can, and I'm going to look for common factors to divide out. Alright? There's a lot of dividing out, including a pair of opposite binomials, 2 minus x and x minus 2. Those divide out to leave a negative 1. After you've divided everything out, there's not much left. There's just 4 times negative 1 times 2, that's a negative 8. And the bottom is just a 3. So the answer is negative 8/3. Next question involves a solving of a rational equation. This is a tough question. I'd like you to begin by looking at these denominators. We're essentially going to look to get rid of all the fractions by multiplying by the LCD. If you look at this denominator in the third fraction over on the right, hopefully you'll see it can be factored. And its factorization is x minus 4x plus 3. That's pretty typical. You also want to know what to do with this subtraction. We always suggested that you rewrite subtraction as addition of opposites. Make it plus negative 1. Okay? So that's what I've done here. I've factored the denominator and I made it plus negative 1. Before we go much further, I'd like you to consider what values, if we got them as answers, would make the fractions undefined. In other words, if I have a particular number here or here and it makes the denominator 0, that can't be, right? And that would be considered extraneous. So write down what numbers you think would make the fractions undefined. So if we get them as answers, we won't include them. Hopefully you wrote down 4 and negative 3. Those are extraneous, if they come up. Okay, so we're prepared for that. It's a good way to approach it. So we know the LCD has got to have an x minus 4, and it's got to have an x plus 3. So let's multiply every term, the numerator of every term, by x minus 4x plus 3. And of course, some stuff divides out. Okay. What divides out here is the x minus 4's, so you have x times x plus 3. Here the x plus 3's divide out, so you have negative 1 times x minus 4. Here the whole denominator divides out, which makes it really easy. We just have a 28. Let's rewrite what's left. Okay. Got an x squared plus 3x minus x plus 4 equals 28. Get everything on the left side. Let's factor and solve. Factorization, solve, but of course 4 was something we listed up top. We said if we get that, that's going to be a problem. It's going to be 4 minus 4 on the bottom. Don't include it. So we won't. If we're subtracting or adding rational expressions, what's the sum of these two? Well, we need to get a common denominator. Okay? Our common denominator is y minus 2 times y. Multiply the top and bottom by y, top and bottom by y minus 2. Once you've got the common denominator, it's pretty easy. You just combine like terms. So we get a y squared plus 10 over y times y minus 2. Last question involves simplifying. If in doubt, factor it out. So the top factors to be difference of two squares. The bottom is a tricky factoring. Pull out a GCF, then you have to do maybe that tic-tac-toe method, factor that out, and then I see opposite binomials. Those are going to make a minus 1, and so our final form is going to look like this. Thanks for watching.